Today we're going to look at this question. Calculate Kp for each of the following. So let's look at the first equilibrium reaction. To calculate Kp, we need to use this equation here. Kp equals the Kc times the ideal gas constant times temperature. And these two products are going to be brought to the power of the change in moles of the reaction. And when I say change in moles of reaction, change in gaseous moles. Let's look at the first question. So the reactant has 2 moles of gas, 1 mole of hydrogen gas, 1 mole of carbon dioxide gas. The product side also has 2 moles of gas, 1 mole of H2O gas, and 1 mole of carbon monoxide gas. We're going to use this equation right here to find our change in moles. Okay, the products had 2 moles in gas, and the reactants also had 2 moles of gas. So when you subtract them from each other, you get 0. We just found that value right there. The change in moles is 0. So one thing we're going to need to know is what is the ideal gas constant, and that equals 0.0821. So we have the gas constant, we have the change in moles, now we need the temperature, and the temperature is here, 1020 Kelvin. So we have that. Now we need the Kc, which is here, which is 0.77. So at this point, we're going to plug this information into our equation and calculate it. It ends up being Kp equals 0.77. This will be times the gas constant, which is times 1020 Kelvin. All this brought to the power of 0. All right, so knowing that this is all brought to the power of 0, we know anything brought to the power of 0 is going to equal 1. So this equals 1. So what happens is we get Kp equals 0.77 times 1. And what that means is Kp equals 0.77. So that's the answer to the first one. Okay, so let's look at the next one. In the reactant side, we have 3 moles. In the product side, we have 2 moles. So same thing. We need to use this equation to find our change in moles, which is going to be 2 moles minus 3, which is going to give us -1 change in moles. And let me rewrite our gas constant, which is 0.0821. And now we have all the information we need. We have Kc, we have temperature, we have our constant, and we have our change in moles. Now we just need to plug that into the equation. Kp equals 1.8 times 10 to the -57 or -56 times the gas constant times 580 Kelvin, all brought to -1. And I already pre-calculated this, and it comes out to be 3.8464 to the -58. And if we round it to 2 sig figs, this is going to be 3.8 times 10 to the -58. And that's the answer. So Kp for this one equals 3.8 times 10 to the -58. And that's how you answer that question. Thank you for watching the video, and I will see you all in the next video.